So let's imagine I live on some waterfront and that I want to fence in my yard to kind of maintain some privacy, but also still have a view of the river. So I look down or I look around and find out that I'm going to have some nice wood or nice fencing on the front side, but I can go for the cheaper stuff on the back side. Here's the information I know. The perimeter of this yard is 1,000 feet. I know the fencing on the front side is going to cost me $25 per foot. On the side, I don't need the good stuff. That's only going to cost me $5 per foot. And all that cost is $9,500 to do that. So based on this, can I determine a couple of things? One of which is based on this, what was the width and length of my yard? Systems can help us discover that. So let's show you how we can use the power of systems to start to unravel some information, so forth. So a system is where we have two unknowns and two equations. So we need to come up with a couple of equations here to solve. First one we know is there's something about perimeter. We know that the perimeter is 1,000. A perimeter is, let's label like maybe this side of x and the length of y. Well, perimeter is y, or length plus width, plus length plus width, or 2x plus 2y. That's perimeter. In this case, we know it's 1,000 feet. So there's one equation. Now we need to try to decipher another equation. The other equation bases on the fence. We know it's $25 per foot on the front, and we call that one a y. So that was 25 times y. The length or the fence on the width, well, there's two x's and it's 5. So it's $5 times two sides times the x. And all that fencing around costs $9,500. Let's clean that on up. You notice I have two equations, two unknowns. First one's 2x plus 2y equals 1,000. And that was probably the hardest part to do, is to figure out what are those equations. And it takes some practice. Don't feel like it's going to come right away. So give us some time, work through, struggle with it, and with practice, it will come. Then we have 10x plus 25y equals 9,500. I want to eliminate a variable. Well, you can do whatever way you want to do it. I'm going to use the addition method. And doing that means I'm going to scale the top one through by a -5. What do you say about that, folks? So it becomes a negative 10x minus 10y equals minus 5,000. The bottom one's still the same. Now I can eliminate a variable, left with 15y equals 4,500. And then y, looks like y equals 15 goes into 45 three times. Looks like that's 300. So I found out what my y value is. Now I have to go back and solve that for x. So I'm going to back substitute that into whatever equation in those systems that looks the best. And I love that first one right there. So 2x plus 2 times y, which is 300, equals 1,000. 2x plus 600. 2x equals 400. X equals 200. So the dimensions of my yard now are 200, 300, and 200. I was looking for 1,000 there, but 1,000 is the other 300 over there. So the fence I have, I'm going to buy 300 feet of the good-looking fence board, and I'm going to buy 400 feet of the bad-looking fence board. And then if my budget increased, I know that my width now, I can determine that maybe if I had $16,000 or so, do I have enough to fence it all around with the good stuff? Well, we can solve that and find that out and go from there. And I'll leave that for you if you're interested. What I hope you discovered here is that we can use systems once we become comfortable with them, once we get good at identifying the different equations at play, then we can solve these systems.